relevance, the feasibility of the project,
Got it.
and whether it's appropriate to use the NPSF infrastructure.
So it's about making sure that the resources are allocated to projects that have the potential to make a real impact in their respective fields.
Exactly.
It sounds like a rigorous but fair process.
It is.
What happens once a proposal is approved?
Okay, so once a proposal gets the green light,
Yes.
the researcher is granted an account and access to the system,
Great.
but their access is determined by the resources they requested and were approved for.
So there are limits.
It's all about responsible resource allocation.
Makes sense.
They also receive comprehensive documentation, user guides, and support to help them get started.
Oh, that's good.
The NPSF team provides guidance and support to ensure users can effectively utilize the resources.
So it's not just about giving them the keys to the supercomputer and saying good luck.
No, not at all.
They provide the support and resources to help researchers navigate this complex environment.
We want to empower researchers to make the most of this incredible resource.
Absolutely.
Now, let's talk about the charging model.
Okay, let's talk money.
We mentioned earlier that there's a fee associated with using AIRAWAT PSAI.
Right.
Can you shed some light on how that works?
I'm curious about that too.
It's obviously a massive and expensive operation to run.
It is.
How do they determine the cost for users? The charging model is based on a resource allocation scheme.
Yeah.
Essentially, researchers are charged for the compute time, storage space, and network bandwidth they use.
So you pay for what you use?
It's similar to a utility bill.
Right.
You pay for the amount of electricity or water you consume.
That makes sense.
You use more, you pay more.
Right, but what about the statement of account?
Yes.
What information does that contain?
The statement of account provides a detailed breakdown of the resources used and the associated charges.
Got it.
It includes information on the compute time consumed by each project, the amount of storage space utilized, and the network bandwidth consumed.
So it's very detailed.
It's a transparent way to track resource usage and ensure accountability.
So it's like a detailed invoice for their supercomputing services.
It is.
It's interesting to see how they've created a system that balances accessibility with responsible resource allocation.
That was the goal.
But let's get back to the technical side of things for a moment.
Okay.
We've talked about the compute nodes, GPUs, and the InfiniBand network.
Right.
But I'm curious about the cabling infrastructure. What's involved in connecting all these components?
Yeah.
It must be incredibly complex.
You're absolutely right.
I can imagine.
The cabling infrastructure is a critical component of any data center.
Right.
And especially one housing a supercomputer like AIRAWAT PSAI.
Yeah, I bet.
Imagine a vast network of cables.
Okay, I'm picturing it.
Meticulously organized and labeled, connecting everything from the compute nodes and GPUs to the storage systems and network switches.
So many cables.
It's quite a sight to see.
It sounds like a logistical nightmare to install and manage all those cables.
It takes a skilled team.
What types of cables are used?
They use a variety of specialized cables, including fiber optic cables for high-speed data transmission and copper cables for power distribution. The choice of cable depends on the specific application and the distance the data needs to travel.
So there's a science to it.
There is.
It's not just about plugging things in.
No.
There's a lot of thought and engineering.
A lot of planning goes into it.
That goes into the cabling infrastructure of a supercomputing facility.
Absolutely.
But let's move on to another crucial aspect.
Okay.
The cooling system.
All right.
We've touched on liquid cooling for the InfiniBand switch.
Yes.
But what about the overall data center?
Right.
How do they keep all that hardware from overheating?
Maintaining a cool and stable environment is absolutely essential.
I know. It's like a server room times 1,000.
For the proper functioning of a supercomputer,
of course,
AIRAWAT PSAI's data center utilizes a sophisticated cooling system that combines various techniques.
Like what?
One key element is a robust air conditioning system.
Okay, so your standard AC.
That circulates cool air throughout the data center, preventing the hardware from overheating.
So it's like having a giant air conditioner working around the clock.
It is.
To keep the supercomputer from having a meltdown.
You could say that.
But I imagine air conditioning alone isn't enough, right?
Right.
What else do they do?
In addition to air conditioning, they also utilize rack density optimization.
Rack density optimization.
Essentially, they carefully arrange the racks to maximize airflow.
Okay, so it's strategic.
and prevent hot spots from developing.
Gotcha.
They also use specialized cooling units called RDHX units,
RDHX. Okay.
which are designed for high-density computing environments.
Specialized. So it sounds like a multifaceted approach to thermal management.
It is.
They're pulling out all the stops to keep AIRAWAT PSAI running smoothly.
They are.
But what about backup power?
Right.
What happens if there's a power outage? That could be catastrophic.
Power reliability is paramount in a supercomputing facility.
It is, yeah.
A sudden power loss could have disastrous consequences,
I can imagine.
potentially corrupting data and disrupting critical research.
Years of work down the drain.
That's why NPSF has invested in a robust backup power system.
Okay, good.
They have a 2 MVA transformer,
Okay.
a 2 mW diesel generator set,
2 milliW.
and a modular UPS system with capacity of 800 kVA.
So they have multiple layers of redundancy
They
to ensure continuous operation,
Yes.
even in the event of a power failure.
Correct.
It's like having a safety net for the supercomputer,
Yes.
just in case something unexpected happens.
Exactly.
This has been an incredibly enlightening deep dive
Thank you.
into the technical intricacies of AIRAWAT PSAI.
It's a fascinating system.
It is, but I'm curious about one final aspect, the commissioning process.
Okay.
Can you walk us through what's involved in getting a supercomputer of this magnitude up and running?
Commissioning a supercomputer is like building a high-performance race car,
Okay, I like this analogy.
where every part needs to be perfectly tuned
Right.
and working in harmony.
Working together.
It's a complex and meticulous process, with a series of steps to ensure that every component and subsystem is functioning correctly and integrated seamlessly.
So it's not just a matter of flipping a switch and turning it on.
Definitely not.
What does it involve then?
The commissioning process typically begins with the installation and configuration of the hardware,
Okay.
including the compute nodes, GPUs, network switches, and storage systems. This is followed by rigorous testing of each component
Okay.
to verify its functionality and performance.
Each one. Wow.
Once the hardware is in place and verified,
Right.
they move on to the software stack.
Okay, so it's a very systematic approach,
It is.
making sure each piece of the puzzle is working correctly before moving on to the next.
Exactly.
What does the software installation process involve?
It involves installing and configuring the operating system, libraries, and applications necessary to run the various scientific workloads.
So many different pieces.
Think of it as setting up the brain of the supercomputer,
Okay, the brain.
making sure it has all the tools and instructions it needs to function properly.
So it's like teaching the supercomputer how to think and solve problems.
That's a good way to think about it.
What happens once the software is installed and configured?
Right.
Do they just hand it over to the researchers?
Not so fast.
Okay, there's more.
The next stage involves testing the integration of the hardware and software.
Okay, making sure they work together.
They run a series of benchmark tests and simulations
Okay.
to verify that the system is performing as expected and that all the components are communicating effectively.
Working together, right?
Yeah. This is a critical step to identify and resolve any bottlenecks or issues
Okay, so troubleshooting.
before the supercomputer is made available to users.
So it's like putting the supercomputer through a rigorous training program and making sure it's ready to tackle real-world challenges.
Exactly.
So once this commissioning process is complete,
Yes.
AIRAWAT PSAI is finally ready to go.
Exactly. At that point, it's ready to tackle the most challenging computational problems across a wide range of scientific disciplines.
It's amazing to think about the level of expertise and attention to detail that goes into building and commissioning a supercomputer of this scale.
It is an impressive feat of engineering.
It truly is a testament to the ingenuity and dedication of the team at NPSF.
They've done an incredible job.
But before we move on to the final part of our deep dive,
Okay.
I'd love to get a sense of what it's actually like to work with AIRAWAT PSAI.
Okay.
Can you share any anecdotes or stories that highlight the impact this supercomputer is having on research and innovation in India?
Absolutely. One particularly inspiring story involves a group of researchers from the Indian Institute of Science who use AIRAWAT PSAI to develop a new drug discovery platform.
Oh, wow. Tell me more about that.
They were able to leverage AIRAWAT PSAI's immense processing power to simulate the interactions between molecules.
All right.
This allowed them to accelerate the process of identifying potential drug candidates for various diseases.
So instead of spending years in the lab conducting experiments,
Right.
they could use the supercomputer to simulate those experiments in a fraction of the time.
Exactly.
That's incredible.
This breakthrough has the potential to revolutionize drug development.
It could really change things.
leading to faster and more efficient discovery of new treatments.
Wow, that's a powerful example of how AIRAWAT PSA is enabling groundbreaking research
Yes.
with real-world implications.
Absolutely.
It's fascinating to see how this technology is being used to address some of the most pressing challenges facing humanity.
It's really inspiring.
It's not just about abstract computations.
No.
It's about making a real difference in people's lives.
That's what makes this field so exciting.
It really is.
The possibilities are truly endless.
Okay, my mind is officially blown.
But before we get ahead of ourselves,
Right.
let's take a moment to reflect on what we've learned so far.
That sounds like a good idea.
We've covered a lot of ground in this segment, from the intricacies of the InfiniBand network to the meticulous commissioning process.
And we even got a glimpse of how AIRAWAT PSAI is being used to accelerate drug discovery.
It's been quite a journey. And in the final part of our deep dive,
Yes.
we'll explore the future of supercomputing in India and the potential for even greater breakthroughs in the years to come.
I can't wait. We'll be right back.
Welcome back to the deep dive. We've spent the last two segments unpacking the incredible power and capabilities of AIRAWAT PSAI.
This supercomputing marvel in India.
We've gone from the nuts and bolts of its hardware to real-world applications like accelerating drug discovery.
It's been quite a journey.
But I think what's really exciting is to look ahead.
To the future.
What does the future hold for supercomputing in India?
And what kind of impact could it have on a global scale?
Exactly.
Well, what's truly exciting is that AIRAWAT PSAI is just the beginning.
Just the beginning.
India has made it clear that they're committed to advancing in the field of high-performance computing.
So this is about more than just national pride.
Well, it's about establishing India as a leader in scientific research and technological innovation.
Exactly.
Which, knowing India's history of brilliant minds, makes a lot of sense.
It does.
And when you think about the challenges facing the world today,
Mm-hmm.
from climate change to healthcare to fundamental scientific mysteries,
Right.
supercomputing plays a vital role in finding solutions.
It does.
Can you give us some specific examples of how future supercomputers in India could be used to tackle these global challenges?
Let's take climate modeling as an example.
Okay, climate model.
With more powerful supercomputers, scientists could create even more detailed and accurate simulations of the Earth's climate system.
So it's about providing the tools to make more informed decisions about our planet's future.
Precisely.
What about healthcare? How could supercomputing play a role there?
The potential in healthcare is immense.
I bet.
Imagine using supercomputers to analyze vast amounts of genomic data,
Okay.
to identify patterns and develop personalized treatments for diseases.
Wow.
Or using AI-powered systems to assist doctors in diagnosing illnesses earlier and more accurately.
It's like giving medical researchers and healthcare providers a superpower,
It is.
enabling them to make breakthroughs that were previously unimaginable.
Absolutely, and it doesn't stop there.
Oh, there's more.
Supercomputers are also essential for advancing our understanding of the universe.
Okay.
From simulating the formation of galaxies to searching for signs of extraterrestrial life.
Wow.
These machines are pushing the boundaries of human knowledge.
Okay, my mind is officially blown.
It's pretty incredible.
It's incredible to think that a facility in India could be at the forefront of these groundbreaking discoveries.
It is exciting.
But let's bring it back to our listener for a moment.
Okay.
What does all this mean for someone who's not a scientist or an engineer?
Right.
Why should they care about supercomputing in India?
That's a great question.
That's a big question.
I think the key takeaway is that the advancements made possible by supercomputing will ultimately benefit everyone.
In what way?
The technologies developed, the discoveries made, and the solutions found will have a ripple effect across the globe,
A ripple effect.
impacting our lives in countless ways.
So it's about recognizing that even though supercomputing may seem like a specialized field,
Yes,
its impact extends far beyond the walls of a data center.
exactly.
And I think it's important to remember that this is just the beginning of a very exciting journey.
It is.
The world of supercomputing is constantly evolving.
And India is poised to play a major role in shaping its future.
This has been a truly fascinating deep dive.
I've enjoyed it.
We've learned about the technical marvel that is AIRAWAT PSAI,
We have.
the commitment of India to advancing in supercomputing,
Yes.
and the potential for this technology to address global challenges and improve lives.
I completely agree. What I find most exciting is that we're still in the early stages of harnessing the true power of supercomputing.
Early stages.
The possibilities are limitless,
Limitless.
and the future is full of potential.
And on that note, we encourage you, our listeners, to delve deeper into this fascinating world.
Definitely.
Research the latest advancements in supercomputing, explore the various applications of this technology, and imagine the breakthroughs that might be just around the corner.
Who knows? Maybe one of you listening will be inspired to contribute to this exciting field.
That'd be fantastic.
And help shape the future of supercomputing, not just in India, but across the globe.
That's a great thought to leave our listeners with.
I hope so.
Thanks for joining us on this deep dive into the world of supercomputing in India.
It's been a pleasure.
Until next time, keep exploring, keep learning, and keep asking those big questions.